This 1, 2, and 1, 3 in college algebra, 2 sections in one day. Today, 1, 2 is about graphing functions, and luckily we know how to use our graphing calculator to graph a lot of functions. They ask us on the first problem here to graph f of x equals x cubed minus 3x. Try to think back to your knowledge from Algebra 2 or whatever. What will this look like? Line, parabola, snake, what's a cubic? Since the third degree that's the highest degree, what's this thing look like? It looks like a snake. So let's graph him on our calculator. Let's punch him in. Clear anything out of there that's already in there. F of x, remember that's just y. We're doing x cubed, so x to the third minus, make sure you use subtraction symbol, 3x. And let's see if it'll fit on our standard window. If not, we'll have to change the window size. So what do? We zoom 6. And let's see if we can see the basic snake-like properties of that guy. Does it look pretty good to us? Cool. So they ask us to graph it. On here, we'll need a table of values. So we can go to our table right here. That's second graph, if you will. I always call it second table. And we want a little bit of positive. We want a little bit of negative. Let's go from -3 to +3 on a table of values. So please make a table. And make your x values go from -3 to +3. And then, obviously, we can see what the y values would be. I thank you, awesome graphing technology. Just write them in, etc. And I'd like to get that -18 on there, So what that means is on this graph right here, we need to adjust our scale a little bit. X-axis. Can we go by ones? Yes or no? Yep. Y-axis, there's 1, 2, 3, 4, 5, 6, maybe 7. I might have skipped one. 6 or 7 spots available. What do you want to go by to get up to like -18, +18? What do you want to go by? 2s? Would that work? If there's only 6 spots available, I go by 2s. That would give me to 12, right? So 3s, okay. So let's label our scale like so. On the x-axis, I just went 1, 2, 3, 4, 5. You don't have to put the whole thing on all of them. Just label in our scale. And on the y-axis, I went 1, 2, 3, and etc. Just showing the reader, which is me. I'm the teacher/reader. I'm the person that's reading your homework, what the graph is all about. And now I'll plot those points. -3, -18. So, my bad. I went 1, 2, 3. There should be 3, 6, 9, 12. That's my fault. 15. 18, etc. 21. Did I make it? 3, 6, 9, 12, 15, 18, 21. Yeah, I made it. Trying to get to there. -3, -6, -9. If you don't need to put them all, don't put them all. It's kind of nice when you're going by a weird number like 3s to put them all. And then we'll plot those points. -3, -18. -2, -2. You got to do a little bit of guesstimating of where that's at. -1, 2, 0, 0, and etc., etc., etc. 1, 2, 2, 2, 3, 18. And because of your graphing calculator, if you can't remember what it looks like again, just go back to graph. The basic shape of when you want to connect the dots together should look like so. So again, this is a basic refresher of algebra, just moving very quickly. Like so. Yep. Next guy. Papa. Get there maybe. Again, another cubic, correct? So it should be looking like a snake. Let's go back to y equals, clear all that info out. Instead of trying to type over it, I always clear it out first and just start over. X cubed minus 3x squared minus 13. Do yourself a major favor and double check that you typed it in right before you start doing stuff, Right? Let's zoom 6 in, see if we can see the whole snake. Remember, it's supposed to look like a snake. Drat. What does that mean we got to do? Change the window, right? So X's probably don't need to change. Let's just mess around. That's the weird thing about it. You just got to do a little trial and error. Let's change our Y scales. So like my Y minimum, I don't know, let's go to like -40 to +40. Let's see if that works. And then I don't want to go by ones. That's what this Y scale is all about right here. I don't want to go by ones, so maybe 5s or even 10s or something like that. It's just whatever, just so you don't have all those little 1 tick marks in there. Graph it, see what it looks like. Can you see the whole snake? That looks pretty good, right? It's very snaky. So, table of values, fill them out. See what we're doing. Let's go to the table. And again, there's my same old from -3 to +3 basics. You know, it's like, woo. So let's see what I did. Again, I'm going to go all the way down to even 5. When you're doing this for yourself, you know, you'll figure out what you need to go by to graph all this stuff. If I went all the way down to +5 on my actual table of values, what's my value that I need to get to? 37. So basically, 15, 20, 25, 30, 35. If you went by 5s, it'd probably be all right because this is 35, and you can plot 37 right above it. Like going by 5s for a y-axis scale is pretty good. So fill out your table, and then make yourself a nice little scale. I did go by 5s on my y-axis scale, but I just listed every other one, you know, 5, 10, 15, 20, etc. And then plot them points and graph them, baby. And then again, to look at what it kind of was all about. You really want to be super accurate with it. You can change your window to what we actually have for a window here. You know, went from -7 to 7 on the x-axis, and from -35 to +35 on the y-axis, going by 5s to make them look like identical. But can you figure out why I wanted to add these bad boys on here? Because if I didn't, I'd stop like right there, you know, and it's like, I'd like to be a little more accurate with my sketch, so I know it's going up there, down there. Just a quick refresher how to graph stuff on ye old calculator. Business property valued at $600,000 is depreciated over 30 years. Quick refresher, what's that mean, depreciated? If the value of the property depreciates, what's that mean to you? Goes down, right? Over 30 years by the straight line method. That gives you a big clue in our book, which I can show you where that's located when we get my math lab. Straight line method means, take a wild guess what the graph will look like. It's a straight line. It's linear. So its value x years after depreciation begins is this, you know, where that is linear because x to the first, it's not quadratic, it's not cubic or anything like that. Graph this function on this viewing window. When they give you this little viewing window information, this is your x parameters and this is your y parameters right here. It's in order. So first thing I'll do is go punch that function in, clear amount, 600 thou. Make sure you get the right amount of zeros. 1, 2, 3, 4, 5. Minus 20,000 x. And then let's go straight to window right away. So there's my actual function itself. Straight to window. X parameters 0 to 30. So 0 is your x minimum. 30 is your x maximum. Scale, I really don't want to go by ones since it's going from 0 to 30. You can make it whatever you want to. It doesn't tell you what scale to go by, so I'm just going to go by 5s. That means there'll be 6 little tick marks in there, you know. And then your y minimum is 0, and your y maximum is 600,000. And you definitely don't want to go by ones on that one. I'm going to go by 100,000s. Hit graph. Whenever they ask you to do this on paper, it's nice to make a little sketch for me. So just a little sketch. Let's go to a spot where there's more room. You can put it wherever, but the sketch looks something like this. This is really 30, and this is 0. My bad. This is 0, and this is 30. That's your x parameters. And this is 600,000 way up here. Cool? And then just sketch me what you see. If you're a straight edge person, use it, you know. I like it, but linear stuff's pretty simple to sketch. What is the value 10 years after the depreciation is started? You have to figure out what 10 years means. Is 10 years, would 10 go in for an x value, or would 10 go in for a v value? Read your information back again. The toughest part about MyMathLab, you got to read instructions. What stands for years, x or y? X. So you could do many things to figure that out. You could substitute 10 into this equation and just do the algebra. You could use your graphing calculator, being how we have it open right now, and you want to know when x equals 10, correct? So if you hit trace, and then it will ask you for an x value, trace 10, baby. Trace 10, and hit equals. It just calculates what the value is when x was 10. So what is the value 10 years after the depreciation has started? $400,000. Mighty simple right there. Any questions about a problem like that? Real basic. Just make me a rough sketch a lot of times. You know, on MathXL or MyMathLab you can't do that, but it helps you on your own paper, and you'll take homework quizzes on paper. Let's try this bad boy again. Let's graph that dude in the window that they tell us. So pause the video, get that done for me, please. So here's the window again, just in case, since that's kind of new. X minimum, X maximum. I went by 2's. Y min, Y max. Never change X res. I don't know what that means or what it does. It always needs to be a 1, you know. So never change that. Graph it. You know it's supposed to be a parabola, but that's the only part of the parabola you actually see in this particular window. So rough sketch of him. Everybody. Put your window parameters right there, 0 to 17, and this is 0 to 300. As, you know, rough guess, something like so. Use technology to find S when t is 15. T is basically your x values, so to figure out when x is 15, you can just hit trace 15, and it will tell you. Trace, and then type the number 15 in and hit equals, and it tells you that it is 152.255. So what's this about? That's about the number of students in thousands of that kind of medicine in the U.S. can be described by this. After 1980, so if t is 15, and that's years after 1980, wasn't that talking about 1995? Right? In the year 1995, there was about this many thousand students studying osteopathic medicine, is what that formula is all about. Use the model to estimate the osteopathic students in 2005. Well, in 2005, we need to figure out our t value, or that's time in years after 1980. We need to take 2005 and subtract away 1980 and figure out how many years that's been first, which is, how's many? 25. Problem, this isn't going to do me any good. Why can't this screen do me any good? Window only goes up to 17. We've got to change the window before we can let the calculator do the work for us. So since I need to get to 25, I'm just going to go straight to 30 on the old X scale and regraph it. It won't calculate things that are not on your window. Got to be in the window first. So now I'll hit trace 25, and it'll tell me. So about 114.555 thousand, or what would make more sense is to write it like that. Oops, how about 555 students? Instead of saying 114.55 thousand students, I took that decimal times 1,000, which moves it 3 places to the right, and then you get about that many. Yummy? Yay for graphing calculator. You'll say that a lot this class. Let's go to section 1.3 now. Rules for linear. You might want to jot these down if you don't know them. These 3 rules to be linear. I'll pause the video, let you do that real quick. Basic rules to be linear. All variables are to the first power. Nothing squared, nothing cubed, no 1/2 powers, no negative exponents, none of that stuff. Every exponent, all variable has to be to the first power. No product of variables, I mean you can't see the 2 variables multiplied together, and there's no variables in the denominator. So they ask here, determine whether this is linear. If so, give the domain and range in set and interval notation. Let's go through the 3 steps. Is he linear? Are all variables to the first power? Oh yeah. Any product of variables? This is a product of a number and a variable. That's okay. It's not 2 variables multiplied together, and there's no variables in the denominator, so is he linear? Yes. Domain. When they don't use x's and y's, it is always interesting which one's the domain and which one's the range. You know domains are x's and ranges y's. Use alphabetical order. So yeah, s's and t's, we will say that s is our domain. It's a line, right? Isn't it a line, correct? Is it horizontal, vertical, or oblique, though? Since there's more than 1 variable in there, that's going to be an oblique line. And if you look up to the right in this nice little picture right here, what's the domain of a line that's oblique? What could x be? Anything you want to. All reals. What's the range? All reals. So let's do our domain in, oh my bad, we have to do both forms, so set and interval. In set notation, it's the domain is the set of all s's, because that's the variable that they chose in this situation, such that s is an element of the real numbers. And the range is the set of all t's, such that t is an element of the real numbers. If it's an oblique line, it's all real every time. And then in interval notation, that's our preferred method, preferred way that goes from negative infinity to positive infinity, both cases. It's an oblique line. How do you know it's oblique? Because it's got both variables in the same equation. If it only had x's, it's vertical. If it only has y's, it's horizontal, like me and Mr. Dreyer like to say. And if it's not horizontal, vertical, or oblique, then it's not linear in the first place. Cool? They're asking us, is it linear? Number 2, is he linear? All variables of first power, no product of variables, no variables in the denominator. Is he linear? Yes. Problem, it's not oblique though. What kind of line is that? Horizontal or vertical? Make a sketch. Sketches help. And if this pen would want to cooperate, we'd be in good shape. Y equals 9. Isn't the blue thing really what we got right here? The blue thing is that line. If you want to make it a little darker to tell the difference between your x-axis and that, it's a horizontal line at y equals 9. Set notation for the domain. Remember, you're reading from left to right for domain. How far left, how far right do you go when it comes to the domain of that bad boy? All real. So it's a set of all x's such that x is an element of the reals. Range. That's tricky. How low? How high? How low does this puppy go? 9. How high does it get? 9. You can't say it goes from 9 to 9. You can't have the same boundaries. The range is only one stinking thing. It is 9. It's not the set of all y's such that y equals 9. It's just 9. Like if you was to graph that and look at your table of values, the y value would always be 9. Right? That's the range on this puppy. So in interval, the domain, very simple. Set of, oh my bad, negative infinity to positive infinity. Range, impossible to write in interval notation. Can't do it. Right? It is impossible. That's why we have 2 different forms. It is impossible to say from 9 to 9 in interval notation. There's no such thing in this one because it's only one number. That's why you have to sometimes put things in set notation. Sometimes you can put it in interval notation. You just can't do it both, so no such thing. 3, is he linear? Nope, why not? Which rule got violated here? Not linear. And then let's put there as a product of variables. Product of variables. If you decided to solve for y, you'd get y equals 5 over x. And then again, you could say that's not linear because there's a variable in the denominator. You know, it's a hyperbola situation, not linear. So good for us. Find the x-intercept and y-intercept of this. You don't have a graph. I just have one to kind of show you after the fact. This is in standard form because it's ax plus by equals c. To find the x-intercept, if you want to put a little note, let y equal 0. To find the x-intercept, you let y equal 0. I think you should put these two blanks right here. X-int equals y-int equals blank. So when you're finding the x-intercept, I bought a new Internight board and it's not as nice as I thought it would be. You let y equal 0. Right? In that ordered pair, you let y equal 0. And to find a y-intercept, you let x equal 0. So I set up two generic ordered pairs like this. Then I can usually do mental math when it's these nice numbers right here. To find an x-intercept, if I let y equal 0, wouldn't 8 times 0 turn out to be nothing? It's like that just ceases to exist anymore, right? Because you let y equal 0. If you solve for x, when you divide both sides by 4, what would x equal when y equals 0? 4. And then the other way around, let x equal 0. Watch your signs is always the tricky part. If you let x equal 0, 4 times 0 is nothing. You're left with this, and don't you get a negative 2 in that situation. If you wanted to graph it, and you have that, then you just plot those points, 4, 0, boom, 0, negative 2, boom, connect the dots, and she's done right there. If you put that in slope-intercept form and made a table of values, or if you put it in your graphing calculator, you get the same stinking answers. But x-intercept, y-intercept, think oppositely and let that variable be 0. Finding the slope. Slope, all kinds of information I have for you. Slope formula. Difference in your y's over the difference in your x's. We're very good when it's an oblique line, but when it is a horizontal or vertical line, I just have this all graphed for you to show you what the slope is if you count rise over run. Check out my red line. Isn't that oblique? How much would I rise? Let's call this point A and call this point B right here. How much would I rise to get from A to B? 0. Run from -8 to -3 is 5 units. Don't you rise 0 and run 5 to get there? And this simplifies to be 0. There is no slope. Excuse me. The slope is 0 of a horizontal line, right? Because there's no rise whatsoever. So 0 in the numerator is good. When you have 0 in the denominator, like if I wanted to get from point C to point D, I would rise 1, 2, 3, 4, 5, 6, 7, 8, -8, and run nothing. Ah! Thou shalt not divide by 0. That's undefined because there's no run whatsoever. So the slope of every vertical line is undefined. If you're a note person that likes to highlight, it's right there. Every vertical line slope is undefined. The slope of every horizontal line is 0. There's tricks when looking at it. You can tell right away when they give you the two ordered pairs if it's horizontal, vertical, or oblique. Because if you look at all the horizontal lines, this is y equals 4. Isn't every y value 4 in those ordered pairs? Correct? This vertical line is x equals 2 because every x values are the same. I can tell right here that this is not horizontal because the y's are not the same, and it's not vertical because the x's are not the same. This is oblique, right? Different x's, different y's. So my slope, we better know how to do that. y2 minus y1 over x2 minus x1, and you get the minus a minus in there. And you get -4/12, which is -1/3. When you have an oblique line, you should get a fraction that is not 0 and not undefined. You will get anything else but 0 or undefined because it was oblique. Is there one more example of this? No. Finding the slope. All right. If you need help with that, come see me. Finding the slope. Good deal? And again, just to show you, I guess I drew that out. Here's those two ordered pairs. Can you tell that that is an oblique line? It is not horizontal. It is not vertical. It's that green one right there. All right, slope-intercept form of a line. Y equals mx plus b, for those who don't remember. Slope-intercept form of a line is y equals mx plus b. M's the slope, b is the y-intercept. They're going to switch things around all over the place. The slope is the coefficient of x. The slope is the number in front of x. So as you can see in this guy, he is in slope-intercept form, sort of, kind of, maybe, just not the way you like it. The amount of money, y, remaining to be paid on a loan of $60,000 with this much interest is this equation. Where did this come from? You borrowed $60,000, which you'll do shortly here, probably within the next 10 years, hopefully, for you buy yourself a house. Probably borrow more than $60,000. If you borrowed $60,000, but what else kind of happens when you borrow from the bank? How does the bank make money? Interest. So that's how much interest there was in the whole situation. Isn't that how much you totally owe the bank then, basically, right? And you're paying $1,275 every month back, right? Do you see that this is the slope because it is the coefficient of x, right there? It's the number in front of x, and this is how much you started with. So what is the slope in the y-intercept? Slope is 1275 or negative 1275? Negative 1275. No x's are involved with the slope. And then your y-int is 76,500. Backwards order. Using the equation in number 6, how does the amount owed on the loan change as the number of months increase? I'll let you think about it for a second. You can discuss with your pal, how does the amount owed, which is y, on the loan change as the number of months increase? Well, that's where a sketch could help you out if you wanted to. You could say this is like 80,000, and then don't you start like right here? Come on, pen. And then what happens to this guy as we go on? Does it go up or go down? If the slope is negative, it goes down. If you made a real graph, isn't time go on the x-axis, and this is the amount of money that you owe? See if you can answer that question. So I put, as the number of months increases, the amount owed on the loan decreases by $12.75 per month. Then we can do number 8. Go ahead and work on that one. There's info. Same thing all over again. Slope is very obviously 0.224, coefficient of x. And then what does the slope tell us about the annual rate of change in percent of Hispanics in the U.S.? Well, we just got to put this number in this blank with the right label on it. You know, what was the label that went with this guy right here? What does X stand for again? The percent of Hispanics. A lot of people are like, should you change that decimal to a percent? In this case, no, because this is saying that it's changing by 0.224%. It's just the slope with the percent. That's the label on it was percent in the first place. So you don't have to do any converting or anything like that. Yeah, finally, something maybe new to you. Company produces and sells a BlackBerry smartphone. Yay for BlackBerries. Welcome to 2004. With the revenue given by this revenue function, R of X, 89.50 times X dollars. Revenue, what does that mean? Do you know what the word revenue is all about? Which is fine if you don't. Revenue is like the money that comes in. Right? You got some revenue right here. Revenue, revenue, revenue. And cost, this is how much it costs to make a BlackBerry phone, where X is the number of BlackBerries produced and sold. So it costs this plus that to make the BlackBerry. Cool. And this is the revenue equation right here. What is the marginal revenue for a BlackBerry, and what does it mean? Well, first we probably better define what marginal revenue means. Marginal revenue is the rate of change for the revenue function. It's probably good to write this down because you'll have a lot of these questions on your homework. Marginal revenue is your rate of change for the revenue function. Marginal revenue is the rate of change for the revenue function. And when I say rate of change, it's very simply, another word for that is what? The slope of the revenue equation. So you have to go find your revenue equation, which is R of x, correct? And what's the slope in that particular equation? 89.50. So, which is 89.50 per unit sold. The marginal revenue is your rate of change. Fancy way of saying what's the slope. And in this case, it's 89.50 per unit sold. Find the profit function. Profit, very simply defined to be this. Profit equals revenue minus cost. This is how much money comes in. This is how much you had to spend. If you take how much came in versus how much you spend, you find your profit. Profit equals revenue minus cost. So, do we have two of those three things? You got a P, an R, and a C. Don't we have a revenue function and we have a cost function, correct? To find P, we need to do this. P of x equals R of x minus C of x. Our profit function will equal, do a little substitution property here, R of x is really 89.50x. Our revenue function was 89.50x. Then here you've got to be very careful. We need to subtract away the entire cost function, which isn't there more than one term in that entire cost function, so we better throw that entire thing in parentheses. I need to take away 54 36x plus 6790. And then you've got to distribute the negative through a little bit right here. You can do a bunch of things at one time. You can take 89.50 minus 54.36. Quit out of this bad boy. 89.50 minus 54.36. And that's 35.14. Is that the right number? 35.14x. And then you really have negative 6790 because you had to distribute the negative. That's a quick formula how this BlackBerry company can just figure out their profit. It's like, this will be your profit for every BlackBerry you sell. Just put that in for X, and that'll tell you how much money you profit, because it took away how much came in for it versus, and took away the cost right away. What is the marginal profit for a BlackBerry, and what does it mean? Marginal, whatever word comes after it, means please find the slope of that particular function. If they ask for the marginal profit, do we have a profit function? What is the slope of that profit function? What is the slope of this bad boy? 35.14. So the marginal profit is 35.14. And what does it mean? It means the production and sale of each additional BlackBerry will result in a profit of 35.14. Every time they sell a BlackBerry phone, they make $35.14. This means the production and sale of each additional BlackBerry will result in this much. 35.14. Future.